Hello and welcome to this repair tutorial, and today we're going to look at a audiolab, and the model number is 8000C, and this is the preamplifier. In terms of general specifications, the preamp output is 707 millivolts. You can have the record output set to tape 1 or tape 2, and that is 100 millivolts. Frequency response is 20 Hz to 20 kHz, and then headphones output is 7.67 volts RMS into 100 ohms impedance. And then for your input sensitivity, for your moving magnet input, if you wish to connect an external turntable, is 2 millivolts. And then if from the rear you select the moving coil input, that is down to 100 microvolts. And then for all of your other line inputs, you're looking at 100 millivolts. The preamp output is set at 540 millivolts, and dimensions width is 445 by 74 high by 335 deep. And the weight of the preamplifier comes in at 6 kilograms. Well, this amplifier was sent to me by Chris Smith, who previously I've done some work for, and really was more so of a general service. And what he advised was that the amplifier had never been worked on before. I think he probably owned it from brand new, and I was more than delighted to undertake the work. So when you look from the top of the amplifier, audiolab, has a very loyal following, and you can understand why. The build quality of this amplifier is excellent, and what I'm always impressed with is just the layout of the circuit itself. You don't have all of these sort of interconnecting cables that you have on some amplifiers, but I understand, of course, there is a price point, and the audiolab equipment or amplifiers, they respectively sell at a decent price. So what was the sort of procedure that you undertake when you receive one of these? Well, there are sort of common issues which can happen with any type of amplifier. But when we look at the audiolab, there's a number of little areas. So the first one is that when you look at the back of the amplifier, what you can see here is this bank of RCA input connectors. And what can happen is over time, the plastic becomes very, very brittle. It sort of just breaks away. And then what you can have is buzzing sounds because no longer is the ground connection making a decent connection when you connect from the rear. So full inspection there, and there was absolutely no signs of any deterioration whatsoever with any of the input RCA sockets. And then the next thing that I'm showing you here is the underneath of the amplifier, and then this is with the plate removed. Now, it's very, very important that you scan all of this circuit board just to ensure that you don't have any dry solder joints. And I'll cover this in all of the tutorials. So you're looking really around areas of stress, so input RCA sockets, where you have your switches and your user controls, your potentiometers, anywhere where stress can be transferred. And what you will find often is that there are dry solder joints. I'm not just taking care of the stress points, I'm also looking across all of those other solder connections, and what you can find is, for example, on the voltage regulators, you can see some deterioration there. So again, all that I'm simply doing is just ensuring that all of those solder joints are good. If they're kind of grey and they're miscoloured, sometimes you might see a slight cracking around some of the solder joints. So go over each one of those solder connections just to make sure that they're nice and bright and there's no sort of underlying issues which will come back and then create issues in the future. And then the next thing to focus on is really to make an ESR measurement of all of the electrolytic capacitors. The electrolytic capacitors in this amplifier are by ELNA. And then in the low voltage power supply section, what you have here, again, is ELNA, but these are the RE2 series capacitors. And the maximum operating temperature is 85 degrees Celsius. Now, these two power components here, which are mounted onto this heatsink, which in turn bolt to the chassis, run generally pretty warm. But I wouldn't say that these electrolytic capacitors are that close. But when they were put onto the ESR meter, and here there are 3 of the capacitors, and then when you look towards the right-hand side of the amplifier, when you were looking from the front, this is the very large 10,000 microfarad power supply capacitor. And that was checked with the ESR meter and absolutely perfect. Really no decrease in capacitance value at all. And the ESR value was 0.0. But what you have here is a small 100 microfarad electrolytic. So that was also checked. And then when we sort of zoom in on the ESR meter, this capacitor here should have been 470 microfarads. And you can see already that it's lost about 100 microfarads. And then if you look at one of the other capacitors, This one here again should have been 470 microfarads, and you saw this for all of these 4 capacitors. So I wouldn't say that the ESR is high. You can see it's very, very low, but the capacitance value is beginning to fail or beginning to fall. So it's very important just to remove these capacitors, and then, as I've always mentioned, you want to put longevity back into the amplifier. Now, what you find with many capacitor manufacturers, and these are the high quality brands which are provided by Japanese suppliers, is that some of the series of capacitors which you see in conventional type amplifiers like this are no longer manufactured. They've switched production away from these sort of discrete type capacitors over to more surface mount, because of course that is where they see the market demand. So it wasn't easy to go out and then source ELNA capacitors, which in this series are termed as miniature. So it means that typically for the one which you see on test here, the overall diameter is about 10 millimeters. And I asked Chris, I said, well, what do you want to do? So I put forward a number of Japanese capacitors, and what we chose was Rubycon. And I took the opportunity also just to increase that operating temperature up to 105 degrees Celsius. And you might say, well, there's no way that capacitor is going to be running at that temperature in this amplifier. And quite rightly, that's true. But what you will find is that the operational hours for the higher temperature capacitors, because they would normally be put into more extreme environments, is a lot longer than what you would see, for example, with the original 85 degree rated capacitors. So I've just simply took the opportunity here just to upgrade them. And because they are power supply capacitors, they're going to be working hard. They're not, for example, the other types of capacitors which are inside the amplifier, which are for signal processing. And by changing these capacitors, as I said, it just puts back the longevity into the amplifier. So once all those capacitors have been replaced, and you can see here the circuit board, and you can see that this is that smaller 100 microfarad capacitor. And that's the nice thing with these audiolab. You can see all the component reference numbers are on the board, and then here for the capacitors, they actually write the value on the board, and even the voltage rating as well. So you can see 16 volt, and 35 volt. Very nice. So once that work was done, the next part is that we need to do a thorough clean of all of the user controls. So that's De-Oxit D5. Even before any cleaning was done, there wasn't any issue on the mechanical switching. You didn't hear anything at all. What I would sort of point out is that typically preamplifiers don't have the same kind of issues that you often see with power amplifiers. So if this was an 8000A for the power amplifier, what you will see is discoloration on the circuit board because of the power components. Because this is a preamplifier, really the only power components that you're seeing are these power components which are bolted to this small heatsink. So you don't get any sort of discoloration of the circuit board, and then also as well you don't get sort of deterioration in the solder, and then also deterioration of the actual tracks on the circuit board. And then here what you can see are these capacitors removed. So as I said, this is the RE2 series, no longer manufactured, replaced by RE3. But again, you can't source those anymore. And I always make the point in these audio repair tutorials, always just make sure that you're sourcing from good known suppliers. So the replacement capacitors which were ordered came from Farnell. So I'm confident then that the supply chain is good. And if it is Rubycon, it's definitely a Rubycon capacitor that's gone into there, and it's not counterfeit. And then the other part here is, of course, then to put the preamplifier onto test. So thorough check through, and then the amplifier also received a thorough clean. But Chris Smith really has kept this amplifier in absolutely pristine condition. So there wasn't even any dust on any of the circuit boards, and just really immaculate. So that sort of brings us to an end to this repair tutorial. So if you have any questions or you need any help or support, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any guidance or assistance you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.